All right, here we go. Section 5.2 this time. This is only going to be the first page. So hang in there. I know it's kind of a lot. It's been a long day, but you're doing great. All right. We are going to talk about simplifying radicals. All right. Now, depending on where you go and whether you did Algebra 1, it's in the middle school or did Algebra 1 in the high school, you might not have seen this before. So these first five here, I'm going to treat like you've never seen. So let's just look at the first one, square root of 120. So if I just do that real quick, square root of 120, I'm going to be pulling up the calculator quite a bit here. Square root of 120, it's some number, okay? I know it's bigger than 10, it's smaller than 11. Why do I know that? Because I know, oh, the square root of 100, that is 10. The square root of 121, that is 11. Right? So the square root of 120, it's somewhere between those two whole numbers. It's probably closer to 11 than it is to 10. All right, so let's just kind of figure out what that is. On your calculator, on one of my calculators, right? So if you have your TI-84, look for the square root button. It looks like a check mark. Just type in 120. What do you notice? Square root of 120, it's a really long decimal. All right, 10.954, whatever. Okay. So what we want to do is we don't want to write that as a decimal. We want to write that as an exact value, right? So if you think of, for example, like 2/3, 2 divided by 3. All right, 2/3, a lot of times people call that point six. If you look at the fraction 1/3, a lot of people look at that and they call that 0.333, and then they just chop it off. All right. So they are getting rid of right, all of the decimals at the end. If you look at the decimal 1/7, all right, that is 0.4128. A lot of people might call that 0.143. But you're losing all of that value there. You're rounding. What we are doing here is we want to take this, what is going on here? The 120, and we don't want to have it as a decimal. We want to keep it as an exact value. All right, so fractions are exact. Decimals are approximations. I don't want to approximate this thing. Oh my goodness. I want to keep it as an exact value. And what we have to do is we call this simplifying radicals. Just how if you have the fraction 2/4, all right, that is not a simplified fraction. All right, 2/4 as a decimal is 0.5, but if you wanted to fully simplify it, you would call it 1/2. Right, so we're going to do the same kind of idea with radicals, with square roots. Another name for a square root is a radical, so I'm probably going to use that word instead. All right, so to look at these values here, one thing that you need to know are your perfect square numbers. All right, so if you don't know these are things that you really need to kind of commit to memory here. So if we just look at them, you have 1, 4, 9, 16, 25, 36, 49, and so on and so forth. What's after that? 49, that's 7, 8, 64. 81, 100. All right, so there you go. There's the first 10 perfect squares. And a perfect square is a number where if you take the square root of that number, you get a nice whole number. If I type in the square root of 49, I get a 7. If I type in the square root of 16, I get a 4. Okay. Um, these are perfect squares. We need to have these memorized. So when I look at the square root of 120, what I need to do is I need to look at factors of 120. All right, so if I look at factors of 120, right, two numbers that multiply to 120, 1 times 120, 2 times 60, and so on and so forth, 3 times 40, 4 times 30, 5 works. I don't know what that is off the top of my head. It's going to be 24. Let's see, 6 works. That's going to be 6 and 27 doesn't work, but 8 works. That's going to be 8 and 15. And then you have 10 and 12. All right, so these are all the pairs of numbers that multiply to 120. So what we need to do is we need to pick a pair of numbers from this list. All right, but we have to always look for numbers in this list that are in our perfect squares. So if you look here, this is 4 times 30. 4 times 30 is 120. So what we can do here is I can say, all right, 120 is 4. The square root of 120 is the square root of 4 times 30. All right, so I can multiply them together. So we have the square root of 4 times the square root of 30. When you multiply numbers underneath radicals, you are allowed to break them up. All right, so let's just kind of think about this. What is the square root of 4? Square root of 4 is a nice number. It's just a 2. All right, so the square root of 4 turns into a 2. Now, the square root of 30, if we type that in, the square root of 30 is some ugly decimal. It goes on forever. We call these irrational numbers. This decimal here will never repeat. We do not want that decimal because we're going to round it at some point, even if we take it all the way to the calculator, right? The calculator does round it eventually. We don't want to do that. So I'm going to leave this as 2 times the square root of 30. And this is what we call a simplified radical. All right, so these two numbers, these are the same thing. All right, if I type them into my calculator, if I type in the square root of 120 again, that gives me, I can't remember what it was, 10.95 and a bunch of stuff. If I type in 2, if I try to type in 2 times the square root of 30, notice I will get the same decimal. Right? But this is a simplified version, just how 2/4 and 1/2 are the same thing. 5/10 and 1/2 are the same thing. The square root of 120 and 2 times the square root of 30 are the same thing. All right, so this is how we break down or how we simplify these irrational numbers or these radical numbers. All right, now something that I do want to mention, if I have two numbers, the square root of A times B. All right, so I have A is some number, B is some number. I multiply them together. That is the same thing as the square root of A times the square root of B is two different radicals. All right, these are the same. This is good. However, if I have something like this, the square root of A plus B, right? So you're adding them together underneath. This is not the same thing as that. This is bad. All right. So on the top one, we are multiplying. On the bottom one, we are adding. All right. The rules for multiply and divide are always different in every aspect of math. All right. So this is a very, very common mistake that people are going to make. So don't let that be you. All right. So we're always multiplying numbers here. So 120 is the same thing as 4 times 30. So the square root of 120 is the same thing as the square root of 4 times the square root of 30. All right, so that's what's going on with these. So let's just look at another one, 192. That is our next one here. So the square root of 192. So what we want to do is we want to break this up. We want to figure out, hey, what are the factors of 192? All right, so if you want to save yourself some time, just divide them by our perfect squares. All right, so 1 is a perfect square number. The square root of 1 is 1. I guess I should clarify. These are the perfect square numbers because I can take the square root of all of these. The square root of 1 is 1. The square root of 4, get out of here. I don't care about Jennifer Aniston. Get out of here. The square root of 4 is 2. The square root of 9 is 3, and so on and so forth. Square root of 16 is 4, right? Anytime you square root these numbers, they give you nice whole numbers, right? You're going to go 5, 6, 7, 8, 9, 10. All right. So those are numbers that you should really memorize. All right. So let's just try them all. So if I just do these 192 divided by 4, is that going to give me a nice number? It does. So that's 48. So we're going to call this 4 and 48. Let's try the next one. So it's 1, 4, 9. Start dividing it by that one. So for 192 divided by 9. All right, so that's a decimal, so we do not want that one. So I'm just going to cross that one out. How about let's just keep going. 16. Can I do 192 divided by 16? All right, that gives me a 12. All right, so we have this list. There are multiple answers here. So notice how, and we could keep going, we could keep checking, and as a matter of fact, I will, but that works. So we have the square root of 4 and the square root of 48. Or we have the square root of 192, which breaks up into the square root of 16 and the square root of 12. All right. Are there any others? Or could we find any more? So let's do 192 divided by maybe 64. I think 64 works. It's 3. All right. So I'm going to write that one down. I think that's the next one that worked. So we had 64 and we had 3. So that's also a perfect square. So that's another one that we would have to consider. So we have the square root of 192. That simplifies down into 64 and 3. All right. So all of these get you the same thing. Um, but which one's the best? All right. So if I were to simplify all of these, right, this turns into 2 times the square root of 48. This one turns into 4 times the square root of 12. This one turns into 8 times the square root of 3, right? So those are equivalently, if we were to get a decimal for all of those, we would get that same decimal. But one of these is better than the other. And let's just kind of go back to a simple fraction, right? If I look at 50 divided by 100, 50 divided by 100, that is 1/2. Right? That's the same thing as 5 divided by 10, right? So those are two equal fractions. That's the same thing as 1 divided by 2, right? So of these fractions, which one is the best? Well, the one that's the best is the one that's in simplest form. All right, so it turns out this guy over here is going to be the best one because look at this square root number here. All right, 3, that's a prime number. We cannot break that one down any farther. If I look at this 48 here, I can keep going. I can simplify this into the square root of 16 and 3 because 16 times 3 gives me 48. All right, notice how I still have that 2 on the outside, so we're going to leave that right here. So this turns into 2 times 4 times the square root of 3, right? These are all being multiplied together. So we have 8 square root of 3. If I look at the 4 square root of 12, look at 12. 12 breaks up into the square root of 4 and the square root of 3, right? So I can keep breaking these down. I still have that regular 4 on the outside. So this turns into 4 times 2 times the square root of 3. In these numbers here, those are like terms. They're both outside of that radical, so you can multiply those. So this turns into 8 square root of 3. And now if you look, these are all the same, right? So that is what they look like fully reduced. So when you have, problems like these, the square root of 192, and you're looking for all the perfect squares, sometimes you will have multiple answers. So you should use the biggest perfect square you can find. In this case, it's 64 is the biggest perfect square. So you want to use that factor pair, right? You can still get to your final result. They end up being the same thing, but this guy is not going to be as good. This 4 square root of 12 is not going to be as good as this 8 square root of 3. That would be like saying, 5/10 instead of 1/2, right? They're numerically the same, but 1/2 is better than saying 5/10, right? So that's just how these square roots work. Um, Anytime you have numbers on the outside like this, so we really have to be careful. Like this square root of 16 turned into just a normal 4 without the radical. So a lot of times, people or students will take the square root of 16 and then they're really tempted to put a square root of 4 here and then call that a 2. We don't want to do that, right? Once you evaluate the square root function, you get rid of that check mark symbol. All right, so now this turns into a regular 4. And then since we have two numbers on the outside, you have a normal 2 and you have a normal 4. You can multiply those two numbers together, and then you're going to leave the square root of 3 underneath that radical symbol. All right, so that's just a crash course on these square roots here. All right. Oh man. So here's a few more. Do I want to do these? Yeah, I'll do number 3. All right. I can hear you guys now saying no, but get over it. All right, this one. Notice that there's already 5 on the outside. So this is 5 times the square root of 360. All right, so anytime there's a number just on the outside, you could put a dot there, you could put a multiply symbol there. That just means it's times 5 times the square root of 360. So let's go ahead and break this up and do some factor pairs. All right, so I know 360, that is just, let's make this a little smaller. 360 is just 36 times 10. Why did I choose 36? I chose 36 because it's in this pair over here. The square root of 36 is 6. Right? So this turns into 5 times square root of 36 turns into a normal 6. Square root of 10, ugly number. You can type it in your calculator, see for yourself. It's 3 point something. I don't know. All right, no human knows what that is. All right, 5 times 6. Those are both on the outside. There's a normal 5 and normal 6. Multiply them together. That's going to give us a normal 30. This is 30 times the square root of 10. All right. I don't want to do these next ones. All right, so I'll leave those to you. I don't know what the answers are off the top of my head, but these will simplify into something. This one is going to be 10 square root of 21, and then the next one, uh, I don't know what that one is, so I'll let you guys figure that one out. All right. I don't know how long this video is getting, but I do want to. Do I want to do this? Coordinate plan is, and we'll call it a day. All right, so that's all I got for you. So sorry this video's got a little bit long. So I will see you guys, when I get back.